This is section 17.5 and it's about indicators in acid-base titrations. And you may be thinking, well, what's an indicator? What's the role of this indicator in an acid-base titration? Well, simply put, an indicator is something that will allow you to determine when the reaction is complete. Okay? For the most part, in all practical applications of acids and bases, if you're doing a titration, well, they are pretty colorless. So there is no indication just by looking at the mixing of the two solutions to know when the reaction is actually complete. So if you are, for example, titrating a strong acid with a strong base, then you know that the pH, the final pH at the equivalence point is going to be around 7. But how do you know when you reach the equivalence point? Because you are trying to find out what the concentration of the acid or the base is, but you don't know when you started the titration. So how do you know when you have reached the equivalence point? So that's where the indicators come in handy, because oops, because they will point you in the direction of when that reaction is complete. And indicators are actually weak acids or bases. Okay, they will have a weak acid base equilibrium. Okay, and what's interesting about the indicator is that they bring some color to the reaction. So your acid could be completely colorless, your base could be completely colorless, but the indicator, by a change in color, will help you determine when you have reached the end of the reaction. And by end of the reaction, I mean the equivalence point of that reaction. So here we can divide the indicator in two forms. We call this the acid form, and the acid form will have a color. What the color is, it doesn't really matter. As long as it's a different color from the base form, then that indicator would be helpful to determine the end point of the reaction or the equivalence point of the reaction. Okay, so the principle here is that the acid form of the indicator will have one color, and the base form of the indicator will have a different color. So through that acid-base equilibrium for the indicator, then you can determine when you reach the equivalence point in a titration. Okay, and what we are looking here is that, well, if the indicator is in itself a weak acid or a weak base, then it will have acid-base equilibrium, and potentially it will also act as a buffer, right? So there would be a range of concentrations in which you may have a mix of colors, or one is will be predominant. So for example, here we are looking at the situation that whenever the ratio of A minus over HA is less than 1, and that means this pretty much means if the concentration of HA is larger than the concentration of A minus, then color 1 predominates. Okay, so that means the acid form is present. All right, and when that ratio is larger than 1, which means that now the acid form is smaller or lower in concentration than the base form, then color 2 predominates. Okay, base form is present. Okay, so keep those ratios there in mind. To it's not that you have to it's not necessarily that the only species present is A minus. It's just that the color would be predominantly belonging to A minus. Okay, and what you want is that this color change, it will depend on the pKa. Okay, remember, if you are write down a pH that is equal to the pKa of this buffer, let's call it a buffer, then that's when you actually want the color change to happen. So right down the middle of that equilibrium. Now, one thing is that you have the color change for that indicator, okay? And a different thing is that you are actually at the equivalence point of the titration, because it's really, really hard to find an indicator that will change right at the moment that you want it. So you want that indicator. The indicator is gonna help you, but the accuracy of this indicator in predicting what the equivalence point is also gonna be limited. Okay, so if the change would occur exactly at the equivalence point, it would be wonderful, but that would mean that you need a special indicator for each case, and that is actually very hard to achieve. So most frequently than not, what we have is this situation. And in this case, this is a titration of strong acid with strong base. How do we know that it's a strong acid? Well, you are starting at low pH, so it's an acid. Okay, there is no jump here at the beginning when you start adding the base. So if it was a weak acid, there is a little jump there, a larger jump if it's a weaker acid, but because there is no jump there, this is strong acid. Okay, and a strong acid, this equivalence point is right at pH 7. Okay, now ideally you will have the change in color for the indicator right at 7, but it doesn't really happen that way. So this is what you see here from this point to this point is the color change region for the indicator. All right, and what you want is that somehow that color change region overlaps with the equivalence point region, because yes, the equivalence point is right here, but actually that equivalence point is, look at this change in volume here, around here, the delta volume for the base is very, very small. So it's an abrupt change. So just a little bit of base will cause that big change in pH. Okay, so you want this indicator to be around, overlapping the equivalence point region in that titration curve. Okay, a little, if it's more down the middle of the equivalence point, probably the better, but anywhere in that equivalence point region, it would be fine. So phenolphthalein is a very common indicator that it's commonly used for strong acid and strong base. All right, and it works pretty well for when your equivalence point is not exactly 7, but around 7. If it's a strong acid with a strong base, that's going to be 7, but if you have weaker acids that also are around that area, then phenolphthalein works pretty well. However, if you have weaker acids and with very small Kas, then what does that mean? Well, that means that the pH, the end pH for the equivalence point is going to be basic, and at that point, well, probably phenolphthalein wouldn't work so well. Okay, we're in a little bit we're gonna look at a table, and that should become more clear. Okay, so if we are working with weak bases, then phenolphthalein is not gonna help us there, because for weak bases the equivalence point is gonna be acidic. So we need indicators that change color in acid pHs. All right, so however, what we are looking here is, remember when we were looking at this graph here, you want this color change region for the indicator to overlap with the equivalence point region of the titration curve. remember that but for weak acid, that titration region is rather small. So you are looking for indicators that will change within 1 pH unit of the equivalence point. For strong acids and strong bases, because the equivalence point region is wider, okay? So like in this case, this is a wider equivalence point region, then you can afford to have indicators that change within 2 pH units of the equivalence point. That means indicators that will change color around 9 or even 5 pH 5. Then you can possibly use those as an indicator for strong acid, strong base titrations. Okay, so here we have several indicators. Okay, phenolphthalein, the one that we were mentioning just a moment ago, is right here. Okay, and what you see here is that phenolphthalein will change around 8 and 10. So, and that's one, actually, whether you believe it or not, that's one of the most common indicators that we use in strong acid and base titrations. Does that mean it's the only one that you can use? Well, no, you can use anything that falls in this region. Basically, you can use as an indicator. Okay, as long as that change in color happens in that region. Okay, so what if we have something different? What if we have this particular acid, and titration of that acid means that you reach an equivalence point that is around 9.3. Okay, so 9.3, we are looking at, well, around here. So this is the equivalence point for that particular reaction. Okay, so remember, for pH 7, phenolphthalein is one of the most commonly used. But that means that if you are using, if your equivalence point is 9.3, well, pretty much phenolphthalein will already be pink at that pH, and you won't be able to see anything. So same thing happens with this indicator. This is gonna be red. You can't possibly see anything there. There's not gonna be a color change, because if you are coming from acid pH and you are going to end up at 9.3, that indicator is gonna be already changed in color. Okay, so these two that are the closer, so we are looking, probably this is a weak acid, correct? So we are looking at a pH range that goes from here to here, 1 unit of pH. Okay, approximately. But the first two, they would mean that they are late indicators. What does that mean by late indicators? They are not late indicators, they are early indicators. What does that mean by early? You will be underestimating the concentration of your acid, because they will change earlier. They will change before you reach the equivalence point. Okay, so the volume of base that you will be using is less than what you are supposed to. That's why you would be underestimating the concentration of your acid. So they are not very useful in that regard, but if you keep in mind that that's going to happen with those indicators, then you can kind of do a fine-tuning on your titration. It's not the ideal case. You want an indicator that will actually start changing color around the pH that you're working. So if we look at this will be changing from clear to blue around the pH that you are expecting the equivalence point. So this one is good. Okay, you will be titrating all the way to pH 9. That indicator is going to be completely clear, and as you approach the equivalence point, then you will detect the change in color, and then you will be have an indication that the reaction is over. Now this one, there is some overlapping for this one, and this is the one that is going to be late indicator. Okay, and it's a late indicator because you will be overestimating the concentration of your acid. Why are you overestimating the concentration of the acid? Because you will not see a color change way before you are past the equivalence point. Okay, so you're gonna reach the equivalence point here at 9.3. Okay, and the indicator is gonna be yellow. You are past 9.3, and then the indicator goes to red, but at that point it's already too late. So the best indicator that you can use for the titration of this acid would be thymolphthalane. Okay, it would be the best for this titration. All right, so this is just about selecting what is the best indicator given the pH. Of course, none of these are all from this point to the left, these are all acidic indicators, meaning if you are expecting an acid pH at the equivalence point, you would use one of those. The closest to the actual equivalence point pH, the better to detect what the change is. All right. So in review, the indicators are substances that you use to determine what is the, or help you locate what the equivalence point of our acid-base reaction is. The indicators are not just limited to acid-base titrations. There are indicators for redox reactions, and believe it or not, there are also indicators for precipitation reactions, even though the precipitation itself could be used as an indicator for the reaction. Okay, but what you want here is to add some color and add a change in color that will hint you that the reaction is complete. Okay, so here the best indicator for a particular titration, you are looking for that indicator that the change in color, okay, and the pKa of the indicator as well overlaps with the equivalence point pH that you are expecting. At that point, well, you know what you are titrating and with what you are titrating it. You just don't know the concentration, but the information about what pH you are expecting, and that's important that you know that part, because if you don't know what pH you are expecting, then there is no point in selecting an indicator, because then you wouldn't know. Okay, you don't know what change to follow. Okay, so that's pretty much all there is to indicators.